Good evening, everyone. People in the back, if you guys can make your way in the front, that would be helpful. How's everyone doing? Yeah? All right, I love the energy. How's everybody's New Year starting? Is it busy, crazy, slow? Busy? Or that? That's fine too. Mine's like that. Events after events, it's crazy. All right, so I am Sonam Gupta. I am your host from AI Camp tonight, and I have my colleagues. I have Maitrey here. I have Zimri and Hissam in the back. They are herding people to come here. So we will be helping you answer any questions if you have about AI Camp, or if you guys want to do any events together. And all right, so who has heard of AI Camp, or who is it here? I see some familiar faces here. Okay. So for those people, I will give 1 minute to everyone to settle down. This is a beautiful turnout. Thank you, guys. You guys are that eager to learn about AI and different aspects of AI. This is great. Okay. All right. So like I was saying, AI Camp, we are a developer community that's spread across the globe. All these red dots that you see on the map, that's where we are. And we are a global AI developer community, and we have many different local chapters, and one of them is San Francisco, as you know. We have many different ways to get involved and have technical troubles. Okay, not touching it. All right. So many different ways for you to get involved with AI Camp. You can host events with us, like if you want to sponsor, if you want to give talks. Feel free to reach out to me, Maitrey, Zimri over there, or just email us at info@aicamp.ai. And if you don't like emailing, we have this Discord community QR code as well. I will come back to this slide again. But you can post your questions. We have many different events that we host. So for example, we have virtual events that you see all the dates over here. Then we have in-person one. The next one is on 28th, which is with our other partners. That's AWS. It's a AI Builder Lab, lots of vibe coding, and all the fun stuff that you can do now. Followed by there's one in February. But in any case, you can find all these events on our website, which is aicamp.ai. Want to give it another shout out here. I think this is an all-day event with lots of cool companies participating, and you get to do, you get to build a lot of projects using these technologies. So make sure that you RSVP for this one. That's on February 13th of this year. Okay, back to the slide. So I want to give a community shout out, and I'm gonna, two to three people, if you guys want to share if you're hiring or looking for a job or looking for a co-founder because it's San Francisco. So raise your hand now. You have, okay, there you go. Thank you.
Hi, do I? We're the Dejima AI. We're trying to we're startup of the company, and then we are trying to make the AI more open for people to, with the low cost, and then you know how you are trying to do the AIs, you have to use the GPUs, but if you want a good GPU, it's pretty expensive. So Dejima AI, they want to make the algorithm part, and then let them use cheaper GPUs. So if you guys are interested to invest, please talk to Akira. He's the CEO, right? Huh? CFO. I'm sorry, excuse me. Yeah, so feel free to talk to him. Yeah.
Thank you. Cheaper GPUs, guys. Cheaper GPUs. Talk to Akira. All right. There was one more person who wanted to give it.
Thank you. Hi, my name's Crystal. I hate public speaking, so this is incredibly awkward. So I moved to the Valley about a week ago, funding my own startup, Promptly AI, always looking for talented developers, funders, any of the above. This is the audience for it, so I figured I'd give it a shout out. Idea is a private all-in-one orchestration platform for AI, so your data never leaves our VPC. For corporate clients, we can actually deploy it within your own VPC, governance, all that good stuff. And yeah, so you choose the token spend. At minimum, you see 2 models. At maximum, you see 6 models. You help us fine-tune our router, and we end up with super intelligence without AI taking over and putting us all out of work. So that's all I got. Come see me afterwards. Promptly with an I, AI.
Promptly AI with an I. Great. Thank you, everyone. Thanks for participating. All right, big thanks to our sponsors today, which is Groundcover, Google Cloud, Cribl, and of course, GitHub for this beautiful office. Today's speakers, we have really good lineup today. We have Shahar from Groundcover, followed by Laxmi from Google, and Nikhil to end the show from Cribl. Now, this is a very important slide. Take a picture, if you will. I'll give you 10 seconds here. So what you have to do is pay attention to what people are talking today. And you can, so there's a whole process there. I'm not going to read it out loud. All you got to do is pay attention, ask questions, and note down whatever your takeaways were. Okay. And you get to win $100 Amazon gift cards. So yeah, please, and your entries, the deadline is January 16th, which is today, by 11 p.m. PST. Need more time to take a picture? Okay, all right, moving on. If I'm moving on, come on. Okay, all right, that's it for me. On to the first speaker, Shahar from Groundcover. Yeah, let's hear it for him. Do you want to use that? So while he's connecting to his laptop, one quick announcement. If you have engaged on the LinkedIn post that you might have gotten from AI Camp, if you comment, engage, repost, whatever, towards the end, I will run a raffle for whomever who has commented on the post, and we will give out $25 Amazon gift card for 2 lucky winners towards the end of the event. Thank you.
Hey everybody, great to be here. I'm Shahar, I'm the CEO and co-founder of Groundcover. Groundcover, to everybody who doesn't know, we are a full-stack observability platform built on top of a very unique architecture called Bring Your Own Cloud, which basically means that we don't host our customers' data, but basically allow them to host it in their own environment while managing it remotely. It has a lot of advantages also when it comes to AI. We're going to talk today a bit about what is changing with observability. Part of this talk will be my guesses about where it's going, right? So bear with me, but observability, regardless of what we do with AI, is going to change dramatically, and that's kind of a lot about what we're going to cover today, how we're going to monitor thinking systems and AI in the future. So you don't need to my convincing that AI is changing everything if you're here today, right? But it's not changing everything in the same way, right? If today in 25 you were an e-commerce shop and doing your thing, operating like you used to, you're probably going to look a bit different in 2026, right? Your audience expects much more capabilities when it comes to AI. They want to search stuff differently. They want to operate differently. They might even want to buy automatically stuff, right? You need to kind of adapt to support what your customer base is kind of expecting at this point. But observability is even in a harder spot when it comes to AI because it's being torn right now between 2 different verticals, which are not necessarily fully aligned and are going to kind of redefine how it will look like in a year or so. probably even faster than that in the rate we're moving right now. On the right, there's kind of what we expect observability to do as an observability platform, right? All of you guys have moved from writing, traditional code, deterministic, modular code, like we used to do like 2 years ago. And all of you are writing agentic workflows and building eventually stuff that are not necessarily fit to the old observability world, right? So we expect our observability system to be able to monitor them, and it has to adapt. On the other end, we also expect the observability system to provide a lot of AI value, right? We want it to investigate, to give insights, to progress in a way that is much more kind of collaborative with agents and humans than what it was used to be before. And these two trends are not necessarily in alignment with what any observability vendor is trying to do right now, and it kind of defines where it will go. We're going to start by talking for a second about how to even monitor, what it means to monitor AI with observability, and mostly talking about what will break, right? Because how AI will look in a year, that's kind of not yet defined, right? But we already know what we have in our hands, and we already know how observability is operating. And observability is a field that is very mature, right? It's been with us for 15 years in its current form. All you guys know what logs mean, metrics mean, what traces mean, right? You don't need anyone to explain it. You know how to use them. But are they really useful for what you're doing right now? That's kind of the question. I mean, in the past, not that far ago, we just talked about it before the show started, but basically, there was machine learning in the past. I don't know if you guys remember that acronym. It was kind of, some of you guys, the elderly in the crowd. So companies doing that, right, were focused on inference, right? We were training our models. We thought that was what we were supposed to do back then. We trained our models, and we usually kind of, if we were a company doing ML, we served them and did inference, and we were concerned about other stuff than the other observability domain, right? We were concerned about GPU monitoring, infrastructure utilization of that, maybe custom model metrics of drift in the distribution of inputs or outputs or anything that kind of could help us figure out what's going on in production. But it was a small deviation from the other people doing observability and like not using inference, and it was easy to kind of compensate for that. Not too long after that, like LLMs, right? People start consuming AI over API, right? That's basically what's happening. People stop training models. Some of you might still do it. Not bringing you down. Keep training them. But most people went to consuming agents and AI basically over API. So we started to care about specific things that weren't there before, right? Model latency in a specific other way maybe than before. Token usage, who heard of that, right, a second ago? Suddenly that's super important. Model errors, which are not exactly how we operated before, and we're going to talk about it in a second. Hallucinations, like stuff that are coming from the response of the agent. But eventually, I mean, looking at this span right now, which depicts the response from ChatGPT, eventually it still looks like a trace, right? I can still look at a trace which depicts the flow at the end of which a GPT API was triggered. I want to see that it's a chat. I want to see the payload. I might care about other attributes like the input tokens or the output tokens, the model that was used. I might even care about specific metrics that I didn't care about before, right? I might want to look at the P90 of the latency by the model that responded because I'm using 5 different models. Great, right? I care about specific things, but to be honest, the traces and metrics like there are today are fine with it. We can abuse them in a way that makes sense, right? We can add attributes to traces, like you just saw in groundcover, of token usage, or we can add another, a metric or another label into a known metric that wasn't there before to track latency by model and not something else, not by API endpoint, right? Maybe you want to dig deeper into a model. But eventually just changing the traces and metrics as they are today was pretty much enough, right? And that's the beginning of LLM observability just maybe a year and a half ago or a year ago. And that's kind of where it's ended up right now. But then came agents or agentic workflows. And to be honest, that gap is not linear anymore, right? And that's kind of what we're going to talk about in a second, because up until now, we were kind of doing that incremental changes of trying to fit whatever we were doing today to whatever we're going to do next. to be honest, agents are super complex, right? Just what we're using now is clearly multi-turn, iterative, complex retrieval pipeline, knowledge bases that are kind of in that, not to talk about guardrails, instructions, tool integration, right? It's endless. It's really, really hard to define what is an agent today, right? Specialists, sub-agents, right? Router graphs. It's almost impossible to comprehend. And the reality is that before, even though we didn't kind of want to think about it because LLMs were like super sexy and interesting, to be honest, it was closer to an API call, right, than anything else. And observability is built for API calls when it comes to tracing, right? It's simple. We know how to describe it. User input, final response, and you got what you need. If we look at agentic workflows, they're very, very different, right? If up until now it was simple, right now an agent will ask itself, what's the user input? What are the guardrails that were set to me? Can I even use what I'm about to use? What are my goals, right? You're used to you want to even see them when you want to see the transparency of the process, right? What are the goals that the agent set before it went along and did something? Gathering context like memory or references from the previous interactions, retrieval of data from documentation or any other knowledge bases that you created, planning what I'm actually going to do, what tools I'm going to use, whatever I'm going to kind of pen out from this moment on, and an execution loop, which sometimes can take hours. Right? We're talking about a situation today where people use coding agents, for example, for sessions that are over 2 hours, right? With endless API calls at the end of them, which uses a model, but the process isn't an API call anymore. And of course, at the end, the final response or an action. So the classical pillars of logs, metrics, and traces, what I want to kind of claim, right? And again, this is coming from an observability vendor which is kind of standing on the cusp of what's changing, is that they're not working anymore, right? And to be honest, I think that our customers are going to say that they're not working in a second from now. And let's talk about a few examples, right? And again, these are anecdotal examples. You might think differently. You might have different examples, but this is kind of my take of examples of what will break. Let's start with logs for a second, right? Logs are a very primitive layer of observability, right? Everybody's using it. Everybody that ever wrote code did a printf to console output or whatever, right? We're all used to thinking like that. They're the most primitive part also because they're human generated usually, right? We're used to thinking about logs as human generated. It's a text with meaning. Now, logs are built to describe trends, right? That's what usually we do with them. To describe trends of something, it can be a complex filter, like a text-based filter. It can be a simple one. And we also, in some cases, use logs to drill into a specific window context that we want to investigate. Why did this log break? Maybe I want to look at logs around it, right? I want to see what happened. I want to figure out what happened in this exact flow that kind of brought me there. But they're very good at describing these two things, right? Example of a standard human-generated log, right? A failed process with some kind of ID. We're used to seeing that, right? And we usually ask ourselves two simple questions. How many times did it happen, right? You all have 50 dashboards like that probably at home. You set monitors or alerts on top of that. You want to know if it happened more than 3 times, I'm concerned, whatever, right? But eventually, we know how to count logs, and we know how to look around them and say, why did this happen? Oh, I get it. Before, this and this was retrieved, and so on, right? So this is the kind of the classical flow of looking into logs and figuring out what they're doing. But the reality is that this doesn't fit anymore when it comes to agentic workflows. We're going to move into something that describes a lot more of decision breadcrumbs than actual simple, meaningful events like we're used to thinking about logs, right? The context span of logs is very limited right now. An event happens, something happened, it has to have meaning for it to be a relevant log, right? Another question is, should they even be human readable? Does anyone care anymore at this point, right? Who even generates them, right? So, did you guys wrote that code? Did someone ever write that code? That's also a question that needs to be asked, but let's assume that they are readable for this kind of purpose right now. They should help us with reasoning paths, right? Of why did the agent do this? What information did it see? What policy was rule was fired? What was allowed, blocked? There's a lot of information that we want to kind of figure out from logs, right? These are typical logs that we're going to see more and more in our log management systems, right? Structured logs, high cardinality logs, and we're going to talk about it in a second, that describe very context-aware events. For example, a knowledge-based call-out to a type of knowledge-based called alert docs, retrieving documentations 12, 19, and 27, and the relevant scores are XYZ. Or a policy being triggered, like a PII policy, the decision of the agent was to block the output with a confidence of 91%, right? Or a tool selected, or anything like that, right? These are the type of logs we're going to start seeing more and more in our log management platforms. But when we come to ask ourselves, why did this event happen, right? Why was this tool selected? Suddenly, that's where things break into pieces, right? Because the reality is that the answer to that is now almost as answering questions like this. Which documents were retrieved before this tool was selected, right? Or from the initial user input, which happened like a half an hour ago, to the end output, how many times this tool was used, right? This is almost impossible. These type of questions, log management platforms are not built for this type of questions. This is more, this is closer to maybe security SIM analytics, right? You're looking at very wide context windows, asking questions about an end and a start, counting stuff with context. This is very complicated to do with every classical log management platform, right? So when you would come over to troubleshoot your agent's decision from logs, it will be very, very hard to do it with the current platform that you have right now. So a question is, why even use logging, right? I mean, if it doesn't work, if it's going to break, why even use it, right? We have traces, we have other stuff, right? There's probably other ways to kind of do that, right? And figure out why was the tool selected by my agent. The reality is that there aren't much better tools for the specific things you need for your AI workflow, right? Because the reality is that AI makes high cardinality decisions. Docs equals whatever, right? Filtered by some condition, intent when I plan to do something. These are all values that change constantly. They're meaningful, right? You would want to query on them. Each one of them is meaningful. A selection, a choice, a goal, a planning, an action. You would want to filter by them, but the reality is that the combination of them is so high cardinality that there's almost nothing to depict them but logs, which are basically events, right? Every time that we go into high cardinality, events in time are easier to depict something than a metric, maybe a trace, which is more oriented into something more closed and kind of predefined. Also, there's no stable schema, right? You guys are changing the agentic workflow every 5 minutes. We haven't even started to get into a point where the feedback loops are going to be so rapid that you're going to change it even for live evaluation of what it's doing. So new guardrails every iteration almost, new tools, new reasoning signals. These workflows are going to change over and over again, changing those inputs of that high cardinality, right? And logs are good with changing schemas. They're built for that. They're built to be schemaless. They're built to be versioned. You're used to thinking about like that, right? I can look at different trends of logs over time, and I expect them to change sometimes when a new version is released, when something happens. This is the way they're built. If we're going to change a schema of a trace, we're going to break 50 dashboards and 20 different alerts in the system, because the trace schema is built to be very, very tangible and predefined in most of the use cases that we're doing, right? We're not going to improvise attributes inside a trace, right? It's not something that you do as much as just pushing in a new string into a log. And also, as we said before, AI has long-lived reasoning context, right? It has memory, it has retrieval from previous steps, it uses knowledge bases, and eventually logs are just better at that, right? Traces are optimized to be for a single request, to be honest, right? They're optimized to depict a stateless event almost, right? In a sense that something happened end to end, and that's it. It has to have a beginning, it has to have an end. And logs are much more fit to a very long context. We're used to looking at trends with logs, how they behave over time, how many errors were there yesterday, how many errors were last month, how many errors were there in the previous version I just released a day ago. Traces will have a very hard time capturing memory, capturing state. They're not built for that, right? So logs can be natively manipulated, but as we said before, these are not the common log management platform you're used to. These are maybe SIEM platforms which are highly aware of analytics of logs, which we're not used to working with. But all this is to say that we can avoid using logs, although they're already not fitting to what you're trying to do. Now, what about your code? A wise man said, someone very intelligent said that by the end of 2026, 100% of your code is going to be written with AI, right? I probably made it up, but it's probably not that far from being true, right? It's not weird to assume that by the end of the year, 100% of your code will be generated not by you, or to be honest, that most of you won't write code at all. It's a different way to say it. And then there's the question of how will logs be used by code-generating agents, right? I don't think we know that answer exactly right now because the collaboration between human and agents is still very prominent when it comes to code writing. How many of you have wrote code with Cloud Code or whatever, and it injected its own logs and asked you to copy it, right? So this is exactly the feedback loops that we're still using around logs, but will it actually need it when it's running a bigger cycle, like, for example, sampling data from production and then making decisions? It's hard to say, right? Will it actually need logs for feedback loops? Would you want these logs? Because you have no idea what this black box is doing, right? Maybe logs are the only thing you'll have left to figure out if that thing you just ship to production with an automated CD is actually doing something that you understand, right? We might need it. We might kind of resolve back to the Middle Ages and look at logs to make sure we understand what the code is doing. I don't know, but that's also a debate to kind of think about. What's going to happen to traces, right? We talked about logs. They're going to change dramatically. What will happen to traces that you're used to consuming, right? Don't panic, but everything. They're just not going to work, right? APM, as we know it today, will not be operating in its current capacity in a year from now. It will have to change, and it will have to change for multiple reasons. And again, this is a moving target. It's unclear yet. But why? First of all, agentic workflows just break the microservice or the monolith concept, right? We used to thinking, as we said before, about stateless operations. You guys are used to thinking about endpoint being maybe the most prominent thing when it comes to figuring out what happened, right? In most cases, a status code and an endpoint API is enough to figure out, oh, it's the card API that broke, right? And I can figure out what happened. So we're used to thinking as things of stateless. When I trigger an API, I give it information, but it's stateless, right? It's not supposed to be determined by something else that happened at the same time with like 50 different possibilities at the same moment. Also, complicated traces when it comes to like microservices communications are 20 microservices long, right? You wrote that code. How much breakdown will you need to figure out what's going on? 50? Right? You won't break it down to 1,000 microservices communicated with one another, right? Unless you're, really fond of breaking down microservices into bits and pieces, right? If a human wrote the code, it will be broken down to 20, 30, 50 spans, kind of propagating across the lifetime of a span of a trace. It will also be limited time. How many APIs do you know beside LLMs that are more than a minute, a few minutes? Right? How many APIs do you know that make sense like that? Do you trigger an API and wait for 2 hours? Usually it doesn't happen, right? So we're used to thinking about a very limited time span. And maybe the most important stuff is that we're used to thinking about it deterministically. And that's going to determine how we treat sampling when it comes to traces, which is critical, right? It's no longer deterministic. Before, if I triggered an API and there was a specific situation with a customer I was querying about, and I use the same information, I get the same response every time, and I can figure out how to kind of use it to manipulate the data. It's no longer deterministic. So this is an example of a real agentic flow trace in groundcover, a simple one that took less than a minute, right? just scrolling through, the endless spans that are basically describing this trace, right? Some of them are bedrock queries with an LLM at the end. Some of them are decisions like tool activations, right, and stuff that are being done. This is the classical waterfall view of a trace, right? I want to see spans of the course of a time. I want to figure out what broke, at what order. These are endless spans. This waterfall was created by this execution graph, right? Most of you know how to read it better, right? You would agree with me? For example, this was just a description of our AI SRE agent, which is basically using kind of a router conductor agent that is operating across 4 different specialist agents, which are querying metrics, logs, traces, and events, right? Each of them with its own execution loop and guardrails and knowledge, and using Bedrock as their LLM endpoint independently, right? Sometimes running in parallel, sometimes running not in parallel. So I can read that much better than the waterfall view, right? It doesn't make sense anymore to look at that like that. If something broke in the log specialist agent in its 50th call to Bedrock, I want to figure out that it happened here, right? Before figuring out that it happened in span number 20K, right? It doesn't really help me. So just the visualization of tracing in an APM is going to change into execution graphs and things that will depict what you guys are building, right? Because you're not thinking about it like that anymore. What about sampling? We talked about it before. I'm not sure how many of you are using tracing today or an APM and sampling the traces. It's very common. If you got to keep every trace that your customers are creating when they're querying your system, you're going to end up with like endless data, right? That you don't really need. So people are commonly sampling 0.5%, 1% of data, right, to kind of figure out what's going on. And it made sense a minute ago, right? If, for example, in the common use case, I have 200 OK on my HTTP API that are exposed to my customers, you would agree that if it happens 1,000 times a minute, it's okay not to see all the thousands, 200 OKs, right? Because I get it, right? I get it's working. I can figure out for metrics what's going on. I don't need to sample everything. So 2 methods came out, right, that are very prominent in the market. One of them is tail-based sampling. You want to figure out exactly how to capture that error trace, right, that you care about. You don't want these 200 OKs. You want that 404 or whatever that broke, 500 that broke. So you accumulate all the spans in the trace, and this is cutting edge, right? Tail-based sampling is cutting edge. You wait to the accumulation of all the spans. Oh, if there's an error along the way, then you sample the trace, right? And where do you keep all the spans in the meantime? In memory, right? Because that's what you do. You use an OpenTelemetry collector or whatever, right? Or a vendor like us, and you store all the spans until you see that error that you care about, and then you sample the trace, right? Try to do that with 3-hour sessions and 50K spans, right? No one is going to be able to do tail-based sampling anymore. That's completely out the window, right? It's over. It's not usable. Okay, so head-based sampling, right? Back to the origins. It's always all good. You know, we can still sample the trace in its head. That's what we've been doing before tail-based sampling. Just sample randomly, right? Every trace that will come, we say this one is yes, this one is no, and we'll see a distribution of the behavior over time. We'll see things kind of repeating over time. The thing is that the flow is really, really high cardinality now, and it's also non-deterministic. Just by a change of a comma in your user input, the entire agentic flow is going to change, right? Try sampling that. It's no longer feasible to sample 1% of that and expect something to be the kind of a description of what you want to see in the world. So that's not good also, right? How we will determine if a trace is good or bad? Before, we used to use status codes, right? If it's a 500, it's bad. If it's a 200, great, right? But the reality is that we're going to need AI to evaluate agentic trace. They're going to be so complicated, and also it's going to be so difficult to understand if they failed, because they could be error-free from an API perspective, and they can even arrive in the time span that we expected and still be completely wrong, right? So we're going to move into a concept of live evaluations that are going to run somewhere, that are also going to cost us money, resources, and kind of operational cost that we'll have to evaluate these traces to figure out even if they're good, bad. Is it something we should wake up at night for? That's going to be really, really complicated to know when we kind of run these things in production. What about privacy? The data sensitivity of these things is going to soar, right? If before most of them were kind of attributes that we didn't really care about, it's something that kind of describes a general customer-facing API. These traces will now hold your customers' prompts, your users' prompts. Did you even intend to take accountability for them when you built that feature? Right? So if your user now puts his bank account, right, in your beautiful agentic workflows that transfer natural language into query or whatever you built, right? Now you're storing their bank account in your tracing system, right? Who the heck meant for that to happen, right? So how do we deal with that? That's a big question, right? Sorry. Pricing, same thing. We're used to paying for span, right? Okay, that made sense when it was like 20 spans a trace. Do I really want to pay for 50K spans in a single trace and without sampling like we talked about before? That's going to be a very, very difficult question. And right now, all the vendors in the market have yet to adapt to that, right? They're still charging us like it was, old 2024 or whatever that was. And what about code instrumentation? We were used to kind of instrumenting an SDK into our code, right? We even wanted to select what we want to sample to kind of send as a span. I care about this. I want to make sure this is a span. I've instrumented the API that I cared about. I want to see that trace. You guys are introducing a new technology every week, right? You're moving from OpenAI to Anthropic to a new framework that you're working with every single week. No one is going to be able to keep up with instrumentation anymore. Might be solved by code-generating agents, which will be good at it. But to be honest, that you're going to lose that feedback loop of what you care about, right? You're not going to be able to instrument things that you care about anymore. So that's going to change as well. So we talked about these two sides before, right? Observability for AI, that's going to break. Hopefully I convinced you. And AI for observability. What AI will transform observability into, right? What value it can produce. Most of us are used to thinking about that piece as a cool chatbot, right? It will be bolted onto the application. There's going to be a cool line where I can say, show me my error logs, right? And then it will show you error logs. That's not where it's going. I mean, that's a very interesting transient, a very fun transient, but it's not where it's going. These two fields are going to merge into something that will change basically how these platforms will behave, because both of them will kind of push observability in an interesting path. Observability was eventually built for humans, right? We decided what to collect. We decided how to sample it. We decided how to structure the data, how to interpret the dashboard or the metric, and eventually how to respond. And it was always between a situation where observability kind of sat between dev and production and collected data from both, right? We covered our dev environment, we covered our production environment. We just streamed data into our observability platform, and we let a user, hopefully, a better SRE than us, to consume the data and make decisions and act, right? But that's going to change as well, because we now expect observability besides that cool chatbot, keep using it, right? We also expect it to feedback loop back into dev. I'm writing every piece of code I'm writing by the end of 26. We agreed on that, right? With code agents. Your CR, that's going to move into automated AI in a second, right? Groundcover is already pushing code to production without human in the loop. So, everybody's going to do it very soon. So the belief that these agents can write code and fix PRs and release hotfixes without input for production, that's not going to happen. So observability is going to be the grid that will push data back into your code-generating agents, your CR agents. We also expect it to push value back into production, right? Because I would want it to remediate. If it happened at 2 a.m. and you know what to do, I don't know, drain the node, do something, right? Why do I have to wake up to do something simple if it's easy? So we'll also expect it to do much more grandiose things that just help us query the data with AI or do some kind of manipulation with AI, right? We'll expect it to be a grid for AI, right? It's going to feed back the dev stage, and it's going to act in the production stage. It's going to be very different than what you're used to thinking of observability today. Your agents are going to generate code, they're going to operate a CI/CD, they're going to decide what to collect, sampling, and all that stuff we talked about. That will be determined by your agent. If an incident is happening right now, why not raise the sampling rate? Why not collect error logs? Why not collect info logs, right, that you didn't drop before? Why not instrument something on the fly and ship it right now to figure out what's going on? So they're going to decide how to collect the data as well and interpret it, of course, and act in production. So observability is going to serve as a grid for everything that we're going to do on top of that. Everything that we have right now in the legacy observability market is not going to be sufficient to support all that beautiful vision that I just showed you, right? Because data ingestion pricing, which you're used to paying by gigabyte, right? AI is going to need more data than you, right? You guys are limited, in a good way, right, with how much you can interpret. You're used to thinking about things in dashboards and metrics and specific monitors. But AI will want raw data in huge volumes of context to make decisions. I'm not sure I can pay for it, right, if I pay for a gigabyte. Manual instrumentation, we talked about it, right? That will also put agents not where you want them. If a human needs to instrument code for the trace to be generated, then the agent loses autonomy, right? You want them to figure out what to sample, how to sample, and get the data. And also SaaS architectures that we talked about, if I'm shipping all this data into a SaaS vendor that stores my data, then first of all, it might break this data privacy that we talked about, and also it will break the trust once I want observability to actually act in production. Would I want that SaaS vendor to hook up to my Kubernetes cluster live at 2 a.m. and make actions? I don't know. Maybe, right? Maybe the word is going there as well. So what is an agentic native platform in end of 26? I don't know. We can decide on that later. First of all, it's built for agent interaction and not human dashboards. We're not going to select these systems anymore by their shiny dashboards and UI. It's going to be thought about differently. They're going to be optimized for data abundance. It's kind of the opposite of what we were used to thinking about, right? We're used to thinking about sample less, garbage in, garbage out, kind of figure out what data you need, focus on what you actually want. They're going to be private, they're going to be local, they're going to be secured, because they will do a lot of stuff that they're currently not doing, right? They're going to be part of your production, part of your CI/CD. They're going to be everywhere, right? If your observability platform won't be trusted, then nothing in the production won't be trusted at that point, right? It will be the data source for everything that you do. And it will be autonomous, as we said, from collection to remediation to everything that comes in between. So we talked about observability for AI. We talked about AI for observability, right? It's unclear where this is going, right? It's going in a lot of different directions. It's clearly going to create a very different observability than what we're used to seeing right now at the end of 26. It's going to be interesting. It's going to be mission critical even more. It's going to drive a lot more AI value than you're used to thinking about right now, even when you write code, right? Thank you so much for the time. Our crew is over here. We're also hiring in SF if anyone is interested, and we'll have to talk to you after that. Yeah.
Wait for the mic.
Yeah, sorry.
Yes, thank you for the talk. Very valuable. A lot of it really resonated with me, particularly the reasoning breadcrumbs for AI. I wanted to know, or want to ask, has your company already solved for this? And if not, do you have any thoughts on how to solve for this?
I mean, we're solving for some of it, right? That's what I said at the beginning, to be completely transparent. I think it's a moving target to a degree that, no, we haven't solved for all of this, right? We're still part of the system. For example, we're moving into execution graphs, as we saw, right? Kind of different visualizations of traces. We're a bring your own cloud company, so we can solve for data abundance and kind of help you alleviate that kind of sampling problem we talked about, and a lot of the issues that we talked about around privacy. But to be honest, on log management, for example, there's still a lot of customers using groundcover as a classical log management platform, right? It's not like we can ditch that and move into something else. So we're also wondering on a daily basis ourselves, where exactly this transition is happening. When will our customers stop even doing things that they do today? So it's going every day right now.
Thank you. Let's connect out of the show. Thank you.
Thank you. We have time for one more question.
To your point about customers still using your legacy system, I'm wondering who you're seeing as early adopters. Are there any trends in terms of the types of companies that you're working with that are moving more towards, I guess, the observability for AI?
I mean, probably 90% of them are sitting right here, right? But every company that is building an agent, right, which is basically most of the modern companies right now are building some kind of agent, right? We'll have to face that problem really soon. Most of the companies we're still seeing that build an agent are still figuring out and not that concerned about it. But we already encounter customers that will choose their next APM by that only. They will not choose it by their log management or anything else. They would choose it by AI observability for real. So it's starting to happen at a very high pace, but happening right now, I would say.
Thank you.
Thank you so much.
All right. I'm here to introduce the next speaker. So Laxmi from Google, may you please come up? And thank you so much.
Okay, thank you, Shahar, for the wonderful talk on observability. I think we'll be kind of covering, a few of the things as how the systems are evolving, how everything is becoming more agentic. So today's talk, I'm going to show you or talk about two things. One is Gemini 3, and the other one is about Cloud API Registry and how you can have have MCP servers discovered by that. But, first of all, welcome to the first AI Camp Meetup of 2026. I'm Laxmi. I'm a field solutions architect with Google Cloud. And what this means is that I build solutions using Gen AI and basically, defining what is possible, and also enable developers to build solutions with Gemini. Is it echoing for you, the audio, or no? Okay, good. Awesome. Good. So we are in the era of Gemini 3, right? So each generation of Gemini models have built on the previous one. So if you talk about the Gemini 1, they were the natively multimodal, and they had a very huge context windows. So with Gemini 1, it fundamentally expanded what we could do. So shifting from just text to video, audio, and images along with text, and how much of it can we do it at one stretch, right? Which is the context window. And then came Gemini 2, where we laid the foundation of the agentic capabilities that we are doing today. Because Gemini 2's models introduced the thinking and the reasoning. And it helped us tackle much more complex ideas. And then Gemini 2.5 Pro was kind of topping the LM arena for more than 6 months. Right? And in November of last year, we launched Gemini 3, which is our most intelligent model till date. And the biggest shift is that Gemini 3 is better at figuring out the context and the intent, right? So you get what you need with much less prompting. So we'll kind of look at some examples about how exactly this is done. But what I would say is that over the last couple of years, we have kind of gone from an AI that simply reads text to something that can effectively read the room. So let's kind of spend a couple of minutes on what makes Gemini 3 different. So it has the state-of-the-art reasoning and multimodality, agentic coding, and then advanced tool use and planning. Awesome. Cool. OK, so when we talk about the sort of reasoning and multimodality, what it means is that with Gemini 3, it can handle the depth and nuance performances across text, image, video, and audio, right? So it's no longer about OCR or understanding parts of it. It's about understanding all the modalities at once, right? And then it could be even deciphering like the handwritten text, which we'll kind of look at today, looking at the videos, analyzing what's happening in that, looking at form improvement for a sports video, or it could be like generating high fidelity visualizations from some scientific concepts. Cool. So, and then again, Gemini 3 is positioned as Google's most powerful model for vibe coding and agentic software development, right? And how many of you here have used anti-gravity? Cool. Awesome. So that's like Gemini 3 is powering that as well, right? So for those of you who haven't used it, I think you should try that out. It's a standard IDE, and you basically have a, how do you call it, active partner, which are the agents which kind of help you develop your solution. Cool. And then this model also marks the shift to long-term agentic capabilities, where the model can, on the user's behalf, do deep reasoning, right? And then I think Gemini 3 was topping the vending bench 2 leaderboard, which basically is testing the ability of a simulated business for a full year, right, without kind of drifting off the tasks. Okay, so that's cool. And now let's kind of look at the sheet. So this is a real sheet that I kind of do every day. And so this is one, seriously. So this is the kind of ones that I have every day for my work. And then if you kind of look at this part, right, at the top one, so this is what I do at the end of a day for the next day. And then as I look into my calendar, then I kind of fill up what are the meetings for the day, and then the paper kind of fills up. So if I kind of give it to an AI, what do you think would be the challenges? Yeah. Okay. Legibility. Okay, fine. What else? Yeah.
Understanding prioritization. Maybe you're not going to all get it done. So nice to haves, wants to haves, maybe going to have.
Awesome. Yeah. Anything else? Yeah, go ahead.
Information hierarchy is clearly out of the page. Hard to right up and down.
Awesome. But I thought it was very hierarchical, right? I've written it. Okay, yeah, but I understand that. You know what this one is? Yes, I completely understand. So legibility, yes, hierarchy. There are a whole lot of things which is like thrown at you. And okay, if somebody comes and asks me, what does your day look like? And I kind of give them this sheet, and obviously they will have the answer that you had. Yes. So what we do next is we kind of just give this to Gemini 3, and I have given as a prompt as I want this sheet, Gemini to analyze this sheet and basically come up with 5 different categories. So one is, what is the core objective and what is the status? And then what is the priority? Then are there any guardrails? Because if you can kind of see here, there's a text which is written at the right side around the top where I'm saying that no meetings after 4 p.m., right? So it's kind of slanted. I've kind of written it. I think I was too lazy to kind of just turn the paper, right? And then what are the real-time interventions and what are the actionable triggers, right? So this is what I kind of want to interpret from this sheet. So this is a prompt that I give. So the code I'll kind of show you at the end. And then with that, this is the output that Gemini 3 gives me. Right, so which is kind of, this has I put it as an infographic using, of course, the nano banana. So let's kind of see that. So one was legibility, right? So when we talk about legibility with Gemini 3, when you're analyzing the media, you do have different levels of, what do you call it? The resolution, right? So you go in from low to ultra high. So something, if I can just go back to my sheet, something over here, right, which is the font size is too small, and then, I don't know, I think I'm kind of missing some alphabets there as well, right? So that gets analyzed. Then again, the other problem. Okay, what is the hierarchy of that, right? So if you kind of look at that sheet, Gemini 3 with such a simple prompt where I'm basically telling it that these are the 5 categories that I need. And with that, Gemini is kind of able to get all of these things, right? So for example, starting at the top, so I'm asking for a morning brief. So it says that, there's a design review at 2 p.m., and I'm kind of running behind. And then it talks about the fixed time slots. And then, what are the hard deadlines? And then what is it which is tentative? And then it also talks about the productivity guardrails that I have, which is I've asked for a deep work mandate, which is 30 minutes of work, deep focus work, and then I've put in a no meetings after 4 p.m. And then it's also kind of able to tell me that, your tentative 4:30 catch-up is kind of conflicting with your productivity guardrail. And then, of course, the prerequisite, right? Nothing works without coffee. And it's also able to identify the real-time interventions in terms of what I've kind of written it in red ink. And it's kind of intelligent enough, it's able to do both the temporal and the spatial analysis. And it's kind of able to say that, okay, this is in red ink, so that's kind of, high risk or a high priority. And then there's a blue ink, and it also talks about the actionable triggers. So I'll just kind of, go back to that image, and then you can see that it's from this sheet, all the points are there, and it gets converted into the form that you see. So that's kind of, Gemini doing a whole lot of thinking and action on your behalf. And this is all that I said. Cool. And again, if you kind of look at the actionable triggers, we are also talking about, I put in a note that I need to call my mom. So it's kind of putting it as a personal priority, but nowhere in my prompt am I kind of telling it to do these specific things. Cool. Awesome. So then as my day progresses, I kind of see that I'm running behind. There are a lot of things to be done. And then, my brain is all cluttered. So I kind of asked Gemini, okay, so look at the red ink interruption and the customer questions node, which is basically the red and the blue part out here towards the bottom left, right? And then I ask it, okay, what is the earliest possible time that I can address these without missing my 2 p.m. review? So review is kind of non-negotiable. And then I'm like, I don't know, I know I need to do that, but I need to find some time to do that, right? So again, Gemini 3 to your rescue. So again, this prompt, and then it kind of goes through a nano banana to come up with this infographic, right? So you can see that with just this prompt, it's kind of able to find out that until 1:30, I've got kind of work to do, which is kind of preparing the slides. And then there is a 2 to 3 p.m. is my design review. So I can't have any interruptions at that time. But there is a time slot between 1:30 and 2. Maybe that's a time to do this work. So I would say, at this point, it's like there are, if you look at the timeline, I would say, I wouldn't have to think about what to do now. I just have to look at my watch and then map it against this timeline to tell you what exactly I should be doing. I think it declutters our brains to a large extent with that. Awesome. OK, so now that you have seen Gemini 3, where can you access it, right? So you can access it in Vertex AI. You could also do it on the AI Studio, Anti-Gravity, Gemini CLI, and of course, you could write your own Python code to access these. And if you're a business teams, you also have the Gemini Enterprise, which is the agentic platform to discover, create, and run all the AI agents. Awesome. So if I kind of go back to my initial sheet, right, what I had to do, there was an item saying that follow up with John Doe on metrics. So if I have to get that metrics, what is it that I should be doing? Good. So what I'm going to do is from John Doe. So this is basically a data set, a public data set from the BigQuery table, and which is the data set is an NYC street trees. And the metrics that I need to send to John Doe is the list of trees which are pyramid in shape and the count of rounded trees, right? So this is the kind of metrics that I need to send. So all of this data, what I want to tell you is there in BigQuery in some table. And if I were to kind of get this data, I could write either the code or get into BigQuery, write a query to access this information, right? Which means that I should have enough knowledge of maybe writing a SQL query. So, but how else can we do it? And that too with agents. But before that, let's kind of take a step back and then look at the current problem, right? So when you build an agent, it needs access to your real-world data and services, right? And you have the MCP protocol, which is the standardized protocol for you to access all your tools or your APIs or your databases. But then if somebody has a MCP server, then it's up to you to figure out where it is, how to access it. Again, what is the authentication mechanisms that you need to use for that, right? So there's a whole lot of fragmentation here. And as a developer, the challenges that you face are, one is discoverability. And then you have all the other problems of governance and security challenges. And then again, if you are setting up third-party tools, you would also require accessing complex and other interfaces, which setting them up itself might be a challenge. So how do you kind of solve this problem? Right, so that's where we can, So that's where we use the Cloud API Registry. So this is basically a service on Vertex AI where you can host all of your MCP servers. So it has a few of the MCP servers built in, but you could always, have your own MCP servers and then host them there with the Apigee API hub. Cool. So again, what this means is that, So again, what this means for the developer is that there's a standardized discovery. You don't have to kind of write any code to find out, what is kind of existing. Then again, for BigQuery, if you want to consume all the standardized capabilities like listing the data sets, listing the tables, or executing the SQL queries, you can kind of do it on one line without writing any wrapper code. Then, of course, you have the unified security. So instead of all the other authentication, you could use the IAM authentications on GCP, and that would kind of help you access all of these services. So that kind of makes the whole task easy for you. And we'll kind of see, what are the different steps involved in that. Right? So on GCP, we currently have 4 MCP servers. So if you kind of log in, these would typically be in the disabled state. So we have BigQuery, we have map tools, we have compute, and the container ones. So once you have that, you can kind of enable them to use them, and each of these servers would have a set of tools associated with that. So these are the tools that you can kind of use. Cool. You could also enable these tools using the CLI commands. So I have provided a notebook through which you can do this. And otherwise, you could always do it from the UI. So get into the Vertex AI and Vertex AI Agent Builder, get into tools, and then enable whichever MCP server that you want. Okay, so all of these things, we talked about the Cloud API Registry. So how does that connect back to what we want, right? So I need to write an ADK agent which will help me get all of those numbers, right? And then what I need to do is just provide these MCP tools that you want to access as a registry tool. Again, you just need to specify the name of your project, your MCP server name, and then you need to kind of just establish the connection with the cloud services. It uses all the IAM credentials that you have. And with that, and then you need to retrieve the tools for a specific MCP server. And as with any other MCP server, you could kind of filter out what tools are allowed for a specific user or specific use case. Good. And with that done, this is how the code kind of looks like, right? So you specify the project ID with the MCP server name, and then you have the registry tools as well. And then once you kind of run the agent, all that you need to ask is, could you find the trees that have the pyramid form? And you'll kind of, behind the scenes, call the tables, get the table information, execute the SQL, and this is the answer that you get. And again, the next question is like, what is the count of trees that are around it? And you kind of get the answer, which is like 41. So here, you really don't have to get into the nitty-gritties of the SQL, setting it up or anything, because somebody in your organization has already created that database, it's already running. And in your agent, you just need to ensure that you have access to that project where this is running. So I kind of just shift a bit to kind of show you the code that's behind this. So I've put it onto the GitHub. I'll share that with you. So again, as I said, you give the image, and then you give the prompt as to what you need from this. And you can use the image either from a GCS bucket, or you can use it locally. And then again, the resolution, right? So I was talking about the high. So unless you set it to high, you will not be able to read something which is a small font. So once you run that, this is the, this is what is extracted by Gemini 3, right? So it kind of says this is the priority stack, then these are the guardrails, and so on and so forth. Then you kind of put it onto the Nano Banana Pro, and then you kind of get the image. So again, I've kind of put it as a task for you. You could kind of, so this is just an example, but in reality, you could use any of the images out there or anything which has a combination of images, text, everything, right? Or if it's a video, something which is kind of embedded in that, you could kind of use a combination of all of that and then try and pass it through this, right? And then set the media resolution to whatever regions that, whatever level you want, and then access it. Then we are also looking at the other prompt that I talked about, the interruption, right? And then how Gemini is kind of able to interpret that. So here we do have a thinking config, which I've kind of set it to high, which is for a high reasoning tasks. Again, you can kind of set it to low or medium, depending on what your use case is. So high of the resolution and high of the thinking level would obviously mean higher latency and higher number of tokens. And then what you could also do is you could kind of include thoughts. You could set that flag to true. And with that, you could have a summary of the thoughts printed out, right? So it says that, OK, I've kind of looked at the constraints and the critical path. And that's how it's kind of able to analyze that I am running behind and there is only the slot at 1:30 p.m. where I could kind of address these two issues. And then I do have the answer. And this answer is what I kind of pass it on to the Nano Banana to kind of generate the infographic. So again, a very, very simple prompt with that. So then we talked about the cloud registry. So to do that, you need to kind of enable it. So you could either go to the UI and do it, or if you want to kind of do it with the G-Cloud commands, that's kind of available there. So it kind of lists everything. Then how do you enable the BigQuery MCP server, and all of that stuff is out here. Then I have also written the agent, which will kind of fetch the counts that we have, which is kind of, just as I said, initialize the API registry. And, then you call the registry tools just as you would call any other tool. And I would also share my other screen. Give me a minute. Yeah, so this is where, I have run the ADK web, the snapshot that I was showing. So it's like, starts with that. It says it's a BigQuery assistant. And then I say, what data sets are available in the project. This is my project. And then could you find the trees that have the pyramid form? And then, what's the count of trees that you have? So that's what we have. And, you always need to know whether this was right. So this is the form as pyramid. And there are 10 rows out here, so which kind of maps with what we have over here. And again, we had the other question where it says that the form is rounded, and you have 41. So the SQL queries kind of validate that. But it kind of saves you a lot of energy and effort in getting that done. Now let me go back here. Right, okay. Right, so the GitHub repository, everything, I've kind of put it as 3 separate pieces, but you could kind of always combine them. So I'll just maybe give you a couple of seconds for you to take a picture of this. And feel free to reach out with your feedback, questions, thoughts, and commence. Sorry. And for more samples, and you want to, like, you have kind of got to the stage of writing an agent. So how do you kind of deploy that agent to an agent engine? So you will have in this repo the whole code for deploying it onto an agent engine on Vertex AI as well, along with a lot of other code on Gemini and other embeddings and stuff. And with that, before I take questions, I'll just ask Aziza to talk about the feedback.
Join us to take a quick survey, and we have some great swag to give you as well. So thank you so much for being here.
All right, we have time for one question.
Thanks so much for interesting presentation. Question for organizations who still want to host their models for one reason or another. Do you have an open source version of Gemini that people can host in their self-managed infrastructure?
So not Gemini, but you would have Gemma models that would be open source, and you can Gemma, Gemma. Yes, they would, of course, be a smaller number of parameters. But yes, you can have the Gemma models, but not Gemini. Right.
Right. Thank you.
Good.
Next speaker is Nikhil from, there he is. Hey, good, how about yourself? Can I use this or just plug it in there? We're good? All right, perfect. This work? No, that's it.
Hey everyone, good evening. So you're going to fall into one or two buckets today, right? I mean, this is a room full of AI developers, and you're probably thinking of integrating AI into an application or SaaS or software that was built, before the advent of modern LLMs, or you're working at a startup or you're working at a newer company where you're looking at an existing software, an existing market, and you're looking how to disrupt, and you're thinking about how do you disrupt that with AI, right? Because frankly, most of the software that we all use day to day, especially at our work, is pretty terrible. And AI has a lot of potential to make that software a lot better. So I want to show you, how do you rebuild an existing experience using AI at its core, and how do you want to think about that over the next maybe like 10 or 15 minutes. I'm standing between, sort of like walking around and mingling with others, so I'm going to keep it quick. But before I do that, I just want to take a minute and talk a little bit about, where I work and what I do. So I work at Cribl. We are a startup, a few blocks away from here. We have found awesome product market fit with, large enterprise customers. A lot of the big guys use us. So 50% of the Fortune 100 use us. Lots of ARR. And one of the motivations for me to come here today is that I'm hiring. So I'll share a QR code right at the end where you can use to apply directly. At Cribl, I am the head of AI R&D. So I get to do a lot of fun things that I'm going to talk about right at the end. I'm based in San Francisco here. I've been, part of this industry for a couple of decades now. Right before Cribl, I spent a little bit of time running most of engineering at Substack, where we ran ML models for spam and abuse classification. And before that, I spent almost a decade working right across the street at Splunk, which is another SaaS vendor. And Before that, I used to work in consulting, where we used to build bespoke software for, like single customers. So I've kind of, have a lot of learnings from building software for just a handful of users at a single customer to like billions of customers. And I feel like SaaS sits right in the middle of it, right? Well, SaaS does not have billions of customers. SaaS typically has thousands of customers, or sometimes millions of customers if you're lucky. And which is really why most SaaS software that we use is so awkward to use and it's so terrible. So one thing I've really learned about SaaS is no one is logging into SaaS for fun, right? I mean, take any application that you kind of like use at work, be that a CRM or G Suite or like a billing solution. You want to go in there, you want to quickly do whatever it is that you're there to do, and then you want to log out. And that's the crux of it, right? I mean, it's software to like help do a part of your job or help you accomplish something. So AI has a lot of potential to accelerate a lot of the value that we can get from SaaS. One fun thing about this is also LLMs, just in the way that they're trained and the things that they're good at. They're especially good at anything that's digital native. And SaaS happens to be digital native, right? I mean, everything is sort of machine data, it's records, it's logs, it's transactions, what have you, right? It's pretty disconnected from like the real world. So you're not like moving robotic arms, or you're not, sort of like dealing with things that connect to the real world. So LLMs tend to hallucinate a lot less when you put them in like narrow boxes to, just accelerate your workflows. And I want to show you a few ways how you do that and, how you break that up. So what I really like to do is when I'm looking at a particular product or a particular SaaS or a particular workflow or a particular tool is I look at workflows, and you want to start by looking at the entry points and the exit points of these workflows. There's usually some sort of a stimulus that kicks a workflow off, right? It might be a user action, so somebody's logging in to do a task. Sometimes it's a system event, like a new transaction was created, or somebody applied to a job on Greenhouse, and then that's sort of like a stimulus for an event, which kicks off like a series of steps. And if you think about it, for most software, you're kind of clicking through various screens. There may be like 8 to 10 clicks required. You're navigating between workflows, products, steps. Sometimes you have to go back to like check on something that you did. And then you have an outcome at the end, which is usually some sort of a state that's updated in the SaaS, right? So you have like a field that's probably shifting from pending to approved, or sometimes an artifact is created, like a PDF or a document, or an email is created or generated. So that's sort of like if you take a really zoomed out view of what software is at its core, or business software is at its core in this case, that's what it really looks like. And it really helps to put on your product hat and just like take a look at what these workflows are before you get into accelerating them with AI. There are different kinds of business software and SaaS software that we all see. Some of it is sort of like daily workbench type of products where you have to like log in and look for something. There's a dashboard. It might be an observability dashboard. It might be a billing dashboard, something of that sort. And then there's some set and forget kind of automation, right? So you have, if you guys have like deployed software in Vercel or any of these low-code solutions, that's mostly a set and forget thing, right? You deploy your software there, it's running your software, it's doing its thing for you, and you don't really have to log in to get value from that product. And the way you want to accelerate some of these workflows, or the way you want to bring in AI, looks pretty different for both of those use cases. So if you're looking for daily workbenches, the type of solutions, right? I mean, you're looking at text summarization, you're looking for sort of just drafting or helping the user categorize or present certain options in a ranked format. Whereas if you're looking for set and forget sort of automation, then you're looking for frequent emails or something of that sort. So it really depends, and you want to like look at the problem pretty carefully and develop a really good understanding of what the user journey looks like before you want to start bringing AI into the fold. When you do start bringing AI into the fold, you want to what I love to do is I like to look for cognitive hotspots. And the way to like measure this is you can either use sort of an instrumentation software. You can look at observability logs. You can look at analytics, and you can really try to understand where is it that your users are spending a lot of time just dwelling on a single page? Where is it that they're making a lot of like repeated edits, right? So you type something in a text box and you sort of like, remove that. Some of this stuff is not instrumented. And one of the first things you want to do before you start integrating AI into an existing SaaS is you want to put together strong instrumentation by using, there's so many products, right? I mean, Mixpanel and Amplitude are two of my favorites in that regard. Backtracking is when you sort of go forward a couple of screens and then you have to like go back because there was something on a different screen that you have to then copy paste or something of that sort. And then clicking on help icons or looking at documentation pages is a pretty easy tell that the screen is super complex or has a lot of potential to be accelerated using AI. Once you have found these cognitive hotspots, I'm going to talk about about 9 different things that you can do. These are the first 3. So you want to decompose those cognitive hotspots into what I like to call intelligence chunks. And when a workflow kind of feels like it has a lot of messy text or a lot of unstructured text, you can literally use any LLM off the shelf and extract it into structured fields. You can help users draft emails. You can help users draft notes and responses and those sort of things pretty easily, and put them in front of the user and track acceptance rates. That's a pretty nice thing to do. And those 2 things pair pretty well, and just accelerates that entire journey of the user trying to just go through things. Up next, you can classify text objects. A lot of scanning around the page for, especially if you have looked at a Salesforce page, which has like so many different things on it. You're like busy scanning around and doing things. It's really easy to engage an LLM to use it as a judge almost, so they can highlight the important parts of a page. Just to make the page a little bit better scannable and more easier to digest. You can also recommend options. Recommendations land best, when they're kind of like feel like choices with clear reasons that you can just do like a one-click accept, or you can sort of like push back on the system and sort of ask it to give you something else. And this is really when AI starts to feel like a true co-pilot inside your existing SaaS workflows, more than a novelty feature. And then validations, like a lot of tools that we all use have pretty complex validations on certain fields. Sometimes you have to write a structured query. Sometimes it's an expression. Sometimes it's a sort of you want to have like, oh well, you can't have like a dash in that or an underscore in that. Those things are like a no-brainer for LLMs, right? I mean, you can just take it, pass it to an LLM, and it can just give you back sort of like the valid field. And it's annoying how many times you have to really do that when you're using software. So those are some of the cool things that you can take into mind when you're thinking about disrupting an existing SaaS using AI, or you're looking to integrate AI into an existing or sort of like a software that predates modern LLMs. Coming up on the summary here, this is a pattern that I found to scale really well. Most people start off with some sort of an assistant, with a chat bot that you can go and ask it questions like, well, how do I do X, Y, Z in this product? And then it tells you, well, you go here, you click on that screen, et cetera. It presents itself as a panel or sort of like a floating action button somewhere on the screen. That's a great starting point. The next step that comes after that is what I like to call wrapping a workflow using AI. So this is when you take a workflow that spans, several clicks or several screens and just compress it down to like a couple of clicks, ideally just one click, or maybe just a handful of clicks to really make it go fast. The boss here is probably the task wrapper, which is sort of like a family of workflows. So this is something that our users are consistently spending several hours a week on. That's sort of like constitutes itself as a family of workflows. You can automate all of those using AI, set it up, sort of like a background agent that is taking away that task family from the user's sort of like day-to-day, week-to-week job. Some tasks are done once a quarter. Some of them are done once a month. Really depends on what sort of industry you're trying to disrupt and what sort of stuff you're trying to do. This is sort of what we are doing at Cribl right now. We are taking a bunch of tasks that our end users are doing. Like one of the really cool products that my team launched was a product for scanning and redacting sensitive information from background tasks, because that's something IT practitioners will spend several hours a week doing, right? So it's a pretty tedious job, and it's a perfect use case for LLMs because they're so good at pattern matching and understanding sort of like, oh, this is a false positive, this is a false negative, recommending regular expressions and those sort of things. So really like this sort of architecture of starting with an assistant, starting to wrap workflows with AI, and then starting to wrap tasks with AI. And then finally, you have unit economics, right? I mean, SaaS or AI LLMs can get pretty expensive pretty fast, especially if you're not paying attention. So here's a nice framework that we use, which is cost per accepted outcome, where we take all of the cost and then we divide it by the number of times the user accepts outcomes. And that gives you a bunch of levers to raise acceptance by using a better UX. Sometimes you have to upgrade the model that's being routed to, and sometimes you can also make things more efficient by using a cheaper model. Some of the acceptance signals are obviously there's a clear thing when customers or users just accept the thing that you're presenting. Sometimes it's, they can make some light edits, which still should count as an acceptance. And kind of time to outcome remains the holy grail of how fast somebody can come in and do their thing and get out of your SaaS and sort of get on with their day. So that's kind of the framework for how you use AI to accelerate existing workflows in the context of SaaS. This is a quick summary of all the cognitive hotspots and sort of the intelligence chunks frameworks that we use. And then shifting gears a little bit, I want to talk, what are we doing when it comes to AI R&D at Cribl? So that's the group I lead. We are in the process of growing the team by a pretty significant magnitude. So if you want to work at Cribl, it's a great company. Come talk to me after. This is a QR code as well that sort of presents you with a form that you can fill out for today's event specifically, and it'll go to my talent acquisition team. At Cribl, we are training detection models. So think about named entity recognition models that are encoder-only architecture that can run at scale. The kind of data that we deal with is sort of tens or hundreds of terabytes every single day for every single customer. So we want really small models that can run really fast, either at line speed or maybe at sample speed sometimes. We are also fine-tuning and training purpose-built LLMs for specific log types. So depending on sort of the workload that users are running, LLMs that can do root cause analysis, anomaly detection, all those kind of fun things, which is also pretty nice space to be in. And then obviously, we're doing everything on the user side of the house, which is just agentic workflows, wrapping workflows and tasks and really deeply understanding what security practitioners and IT practitioners are doing with the products, and then how do we help them, make their job easier and accelerate things with AI. And that's all the content I have. You can reach me at my last name, mungel.com. You can find me and we can connect on LinkedIn, or you can scan this beautiful QR code that gets you to a form if you're looking for a job. Thank you so much. Are we doing questions?
We have time for a couple questions.
Yeah.
Hi. So you mentioned for your finance you were using a capo model. I was wondering if you've thought about how, for edits that aren't accepted, bad actors could potentially abuse that and cost you money. So how would you tackle that if that's something you've thought about?
Yeah, so you can measure, sort of if somebody is approaching your product with a positive intent or not. It's just, a variation of the anomaly detection problem, right? So you can just look at that. When you are dealing with SaaS, I will say, it's not something that you have to deal with on a regular basis since you're already dealing with existing customers who are paying you money. But, at my last job, for example, there was sort of one of the things I did a lot, which was sort of detecting abuse at Substack, at detecting spam, people setting up fraudulent publications just to mass email everyone else. And we were able to do a pretty good job by just looking at metrics and looking at data to find anomalies.
Thank you.
Of course.
I see one more question is all the way in the back.
I think she's coming
For
with
the
the
mic, she's coming.
How's it going? My name is Joshua. Nice to meet you. This is so cool. I'm at GitHub right now. It's crazy. I use GitHub every day. I'm curious about, like, you talked about the AI assistant, wrapper, like that kind of workflow. I'm curious, maybe in the more low-ticket SaaS areas, what type of assistant do you feel like provides the most value to the end user and maximizes retention? I know that's a kind of general question, but I'm curious about that. Thank you.
Yeah, of course. When it comes to assistants, I feel like, as you go down that maturity model, right? I mean, you have an assistant where you have to type in your question and ask the system for something, and the system helps you with something. The second level is when the system infers when you run into some problems, right? Whether be that an error message on the page, be that just looking, like correlating a bunch of signals that are happening inside your product. And then I feel like the maximum productivity boost simply just comes from wrapping an entire workflow. So if you think about a typical product, there's a pretty sort of like a long tail distribution when it comes to workflows. Like even when you look at, for example, Google Slides, right? I mean, the menu has like 50 different options. Probably a couple of them are used the most. And if you just focus on those, that's like the way to just kind of like sort by leverage and just focus on those things. And then kind of like forget about like the long tail and not worry about use cases that are not frequent. Yeah, kind of like just filter it down.